Welcome, everyone. Today, let's talk about a genuinely transformative solution to our ever-growing plastic waste crisis: chemical upcycling. This isn't your everyday recycling, which often results in lower-value materials, a process known as downcycling. Chemical upcycling is far more ambitious. It focuses on chemically converting discarded plastics into completely new, higher-value materials, chemicals, or even fuels. Essentially, it's about turning trash into treasure, creating a truly sustainable, circular economy for plastics. Why is this so important? Well, traditional mechanical recycling has its limits. It struggles with mixed or contaminated plastic streams, and the plastic itself can degrade with repeated processing, limiting what it can be used for. While some chemical recycling recovers basic building blocks, upcycling specifically creates products with better functionality or higher economic value than the original plastic. So what are the core strategies? One key method is depolymerization. Think of it as taking plastics like PET, common in drink bottles, and breaking them down into their original molecular building blocks. These can then be repolymerized to create brand new, virgin-quality plastics or completely different polymer structures. Another major approach is pyrolysis. This involves heating plastics to high temperatures, typically between 400 to 800 degrees Celsius, in an oxygen-free environment. This process breaks them down into pyrolysis, oil, gases, and char. With catalysts, we can even steer this process to produce specific fuels like jet fuel or valuable chemicals. Then there's hydrogenolysis and hydrocracking. These methods use hydrogen and catalysts to break the strong carbon-carbon bonds in polymers like polyethylene and polypropylene, common in packaging. This can yield liquid fuels, lubricants, and waxes. Some techniques even convert plastic waste directly into high-value carbon materials like carbon nanotubes or graphene, useful in electronics and energy storage. The range of value-added products is impressive. Those PET bottles I mentioned? They can go back to being high-quality PET or be transformed into fine chemicals or even hydrogen. Polyolefins from packaging can become fuels and lubricants. Polystyrene, that tricky foam packaging, can be upcycled into valuable chemicals. Even mixed plastic waste, which is a nightmare for mechanical recyclers, can be processed via pyrolysis into oils or converted into carbon materials. Innovation in this field is rapid. Scientists are developing highly efficient catalysts that can direct chemical reactions more precisely and under milder, less energy-intensive conditions. Light-driven and electricity-driven methods are also gaining traction as greener alternatives. However, chemical upcycling isn't without its challenges. A big one is cost. It's tough to compete with virgin plastics made cheaply from fossil fuels. Many processes are still energy-intensive, though work is underway to reduce this. Dealing with the complexity and contamination of real-world plastic waste also requires robust technologies. And, of course, scaling up promising lab-scale techniques to industrial levels needs significant investment. Despite these hurdles, chemical upcycling offers a powerful toolkit to redefine plastic waste. It's about seeing waste not as an endpoint but as a starting point for a new generation of materials and chemicals. Continued innovation, supportive policies, and investment are key to unlocking its full potential and driving us towards a truly circular plastic economy. Thanks for tuning in.